We already talked about the common ion effect on the solubility. So now we're going to talk about the effect of pH on solubility. The solubility of a substance can all depend on the pH of a solution. As an example, look at the solubility of the magnesium hydroxide. Magnesium hydroxide dissociates into magnesium 2 plus and hydroxyl ions. So we can write the Ksp using the S as the molar solubility. So S squared with 2S and S multiplied by 2S squared, which equals to 4S cubic. And when we solve it, we get the solubility as molar solubility as 1.4 times 10 to the negative fourth. So at equilibrium, the concentration of the hydroxide ions will be equal to 2 times 1.4 times 10 to the negative fourth, because by dissociating magnesium hydroxide, by dissociating 1 mole of magnesium hydroxide produced 2 moles of hydroxide ions. That's why I had to multiply the molar solubility by 2 to get the concentration of the hydroxide ions. So I'll calculate the POH by taking the negative log of the concentration of the hydroxide ions, which is equal to 3.55. So what is the pH of this solution? Since we are familiar with the pH. Yes, pH is 10.45. So, in a solution with a pH less than 10.45, the solubility of magnesium hydroxide would increase. How that would happen? Because when the acidity is increases mean we have more H3O plus ions in the solution. These H3O plus ions will actually react with hydroxide ions and make it water. So we are increasing if the we are decreasing pH mean increasing the H3O plus ion concentration, hydronium ion concentration, which actually decreases these hydroxide ion concentrations. So, if you remember the Le Chatelier principle now, by decreasing a product means the equilibrium shift forward or making more products. Making more products mean the solubility of magnesium hydroxide will increase. That's how the in decreasing pH will increase the solubility of a hydroxide solid. Look at this, the solubility of barium fluoride uh, dependence on the pH. The pH of this or the anion will be the concentration or the existence of this anion is affected by H3O plus, because it is an ion from a weak acid. So these fluoride ions will react with the hydronium ions and making this hydrofluoride and water. So in with the high hydronium ion concentrations, the solubility of the barium fluoride will increase, because these fluoride ions will be taken by H3O plus, so the concentration of fluoride ions will decrease, and therefore according to the Le Chatelier principle, the equilibrium will move forward, making more products, or may increases the solubility of the barium fluoride. Right. The solubility of the salts containing the chloride, bromide, or nitrates, they are unaffected or they are not affected by pH, because these ions are the anions from strong acid. So the anions or the cations from the strong acids or the anions of the strong acids are not affected by the pH. Only the anions from the weak acids are affected by the pH or the hydronium ions. Practice problem 5. Which of the following compounds will be more soluble in acidic solution than in water? Solution A, copper sulfide, solution B, silver chloride, and solution C, lead sulfate. So, what we should do? Yes, first we write the KSP or the equilibrium expressions for the solubility of these solids. The copper solids produces copper 2 plus ions and sulfide anion. Actually, this sulfide anion is a conjugate base of a weak acid. Therefore, okay, so it reacts with the H3O plus. So it will make, with the reaction between sulfide and hydronium ions produces the hydrogen HS minus plus the water. So therefore, the acidity by increasing the hydronium ions actually increases the solubility of the copper sulfide, because in the presence of higher H3O plus concentration reduces the sulfide concentration. So according to the Le Chatelet principle, it will the equilibrium move forward to make more products. Next, we talk about the AgCl. It will the dissociation of silver chloride produces the Ag plus and chloride ions. Actually, chloride ion does not react with H3O plus because it's a conjugate base from a strong acid hydrochloride. Next, we talk about the lead sulfate dissociation. It produces lead ions and the sulfate ions. Sulfate ion is a conjugate base of the weak acid bisulfate. So it reacts with the hydronium ions and making the bisulfate ions and H2O. Right. So again, with increasing the H3O plus ions or decreasing the pH will increases the solubility of lead sulfate. So the solubility of copper sulfide and lead sulfate are affected by the pH of the solution. They will become more soluble under acidic conditions.